So my goal for the presentation today is really it's really pretty high level. So what I'm hoping is to spark a little curiosity or maybe just motivation to for us all to spend a little bit more time looking into the history and philosophical aspects of statistical inference and kind of how it's used in science. So I'll walk through a little bit of kind of my background and a little bit of history and some just thoughts that I have for kind of some things that we can all be doing. Of course, now it's not moving forward, my slides. Oh, okay. So to start, I think it's helpful to give you a little bit of my path and perspective, because it has definitely influenced where I've ended up today, as is true for all of us. So I started out in biological science fields. My undergrad's in biology, biomed, and then I switched a little bit to ecology, and then ended up in a master's program for kinesiology, like studying the human movement. And throughout my undergrad and first master's degree experience, I definitely found that I love the philosophy and research methods content of classes, but I didn't actually pursue it in a formal way, and feel lucky that I got little glimpses of it here and there, but nothing really formal. But really an underlying, when I look back now, there definitely was this underlying theme of kind of curiosity about how and why we're doing science the way we're doing it, both from practical perspective and philosophical perspective, as opposed to just like, I want to be in a lab doing science now. So I think a key point in my history, or maybe a sharp, I'm not sure if it was a left or a right turn, but a sharp turn came at the time when I entered a PhD program in motor control and biomechanics. And this was one of the top programs in the nation at the time. I was super excited. I had this extremely romantic vision of what research was, and I was going to be in my lab all the time and really really learn how to do great research. And I really was focused on the philosophical part of the PhD. Like, I really thought I was going to get that piece. When I got there, it became pretty clear really quickly that there was a pretty light emphasis on research methods. So I could have done my whole PhD there without ever taking a research methods course. There was one that you could take kind of if you entered at the right time. Very little talk about study design, so no courses in study design. I wouldn't have taken a class in statistics. There really wasn't emphasis put on having a deep understanding of statistical inference. However, there was a lot of emphasis on actually using statistics in the work that we were doing. And typically that was defining kind of whether a study was a success or not, which you guessed it, like based on p-value criteria. So we spent a lot of time sitting around a table talking about p-values and reusing data from one experiment for multiple questions. And this was like 25 years ago. Before this, like, we were all talking about doing this type of thing. But the problems of doing this type of thing weren't really out in the open. And I didn't really understand the problems, but I had this just kind of gut discomfort with the whole thing. And I knew I didn't know enough to know what the real problems were, put words or languages to that very much. But it was at that point that I decided I needed to pursue something else to like really feel fulfilled about my science. So a little disillusioned, I left that program. I didn't actually know I was going to pursue a degree in statistics right when I left, but I made that decision probably within like a month of leaving. A couple of years ago, I was going through file folders. I actually found her that I wrote to my PhD advisor when I left, and she was incredibly gracious at the time in the conversations that we had. But I just want to put this little quote out there from it. So there seems to be in the lab an overall emphasis on numbers and statistical significance rather than the answering of a question and the conducting of an experiment in the best way possible. So I was kind of surprised, like from my 24-year-old self, to like see how my my discomfort or my issues that I had with that PhD program did really have a lot to do with some of the same things that I'm worried about now, even after my master's and PhD in statistics, plus like lots of years working with researchers. So just like going into my degree in statistics in retrospect, like I had very little knowledge of what would be included in a statistics degree. Based on what I had taken 2 stats classes, and they were very formulaic, like really focused on calculators. That was like about it. And I just didn't even, like, distinctly remember having the feeling like, how could you get a master's or PhD in statistics? Like, well, how could there possibly be enough there? And like, keep in mind, I'm coming from biology where the graduate degrees have a very kind of different feel to them and less course motivated, but I know what I was expecting to learn, kind of why we have this huge reliance on statistical summaries in science and like the justification for placing so much inference on it. So I really had this thought that it was going to like open up this like door for me in terms of my understanding of why in that graduate program I was in, were we doing things the way that we were doing? Like maybe it was okay, and I just didn't understand the foundations and there wasn't anyone to explain it to me. So, well, what did I find? Well, probably the same thing that all of you found, or maybe are finding. I hear there could be some students in the audience, so I'll try to bring in that perspective a little bit. So most, if not like almost all, the education and research that I was involved in through my graduate program in statistics was conditional on the decision to use statistical inference as it appears in most textbooks at the time, right? So there's just like, you go into a class and like, this is where we're starting, is with what's ever in the textbook. And there's very little discussion about how that information got there. So like, how did we end up with what was in the textbook? It just makes it seem like there was no other way things could have really worked out, right? Like that's just, it was inevitable that would be there, which I don't think is the case. Very little philosophy of science and research methodology, even in a PhD program. And I know this is, I think this is pretty true in statistics programs, that there's not a lot of philosophy of science, I think. But I also have seen a shift over my like 20 years of serving on committees to having less philosophy in even other discipline PhDs. So I'm speaking very generalizing a lot here. So I know it's not always the case, but so seem to be pushing out that philosophy of science stuff to get in more like things like computing and statistical methodology. Very little exposure to unsettled foundations or arguments, right? Which is kind of what I was like looking for. I'm like, what do people argue about here before it ended up in the textbook? So just a little bit more on the educational journeys. So this is a little repetitive, but yeah, we had like really focused on doing statistical analysis, because that was the end thing that we wanted people to come out of the degree with. And with this attitude, this kind of unsaid attitude, like it's an integral part of the scientific process. That just is how it is. We focus on mathematical derivations, assumptions, optimality criteria, proofs, a lot of computing, getting to be more and more computing. And with the little recognition that we're conditioning on so much, even to like get to that point where we start doing the stuff that we spend a lot of time on. And so just for example, just like a couple really simple things, well, no, they're not simple, but a couple like things that you can point to that we condition on a lot without thinking about, are just using models for means, right? So we tend to jump right to a focus on averages and models for means because that's what we have available, and very rarely actually step back to think about, okay, well, is actually a mean the thing that I'm interested in here? So that's just one little example. The idea of like what we're conditioning on before we even start, I think, is just a really important question to sit with. And it doesn't have an easy answer. I don't expect anybody could actually answer this fully. And it completely depends on the context of a particular problem as well. But just this idea of like, of just having the thought of like, okay, well, what am I already taken as given when I sit down to work on this project or collaborate with this person or whatever, give my advice as a consultant or collaborator. And so there's a lot of directions that I could go from here in this talk. And I chose today to kind of focus on one strand that I find kind of particularly fascinating. And I think we just don't quite talk about enough in general as statisticians or scientists in general, or decision makers. And I think a lot of this depends on recognizing the norms in which we are living. So, and by norms, you know, I'm really thinking about like really kind of our whole scientific culture, which I could call a paradigm. There's a lot of different definitions and meanings for paradigm, but I think I like this version of it. And by it, I mean the theories, the scientific theories, the choices of methodology, the procedures we're using, the incentives, and I'll talk a little bit more about this as well. So just the idea of acknowledging and being aware on a daily basis, hopefully, that we operate within a particular culture, that we inherit societal norms, defaults, assumptions, modes of operations, or like the how we do it. So there's been so many times where I've kind of tried to dig in with a researcher, like, okay, well, you know, why are you taking this approach, and why was this the direction you went? And the answer, you know, often comes back as, well, it's just how we do it. Like, I don't know why I would do it that way. It's how we do it. So this is like really, it does happen so much. And I think that we recognize on a day-to-day life that we live within societal norms and that we're influenced so much by it. But I think it's really hard to admit that in a science and decision-making setting. Seems much harder than in the social areas of life, but science is still a social process. And you know, how we have to, well, we don't have to, I think we should though, really try to spend time thinking about, you know, what are we accepting without questioning, and how can we gain perspective to see potential limitations in our methodology sooner. I think a key piece of this is kind of recognizing that how we do science is not a finished business. So we tend to teach it like it's a finished business from elementary school time on. I mean, we teach a lot of science like that, right? Like here's what's been discovered, rather than focusing on or rather than acknowledging that, hey, here's where we are right now. But this, as part of science, this is the process of doing science also changes, not just the knowledge that we collect. So in that, along that line of thought, I just want to give some of you know, what come to mind first for me in terms of like, okay, well, what's in the scientific culture that we're living in, or like what's in the paradigm that we're currently under, and what are some big things that pop out to me relative to our use of statistics in science and decision making. And I think the biggest thing is just we are very methods focused right now, or I feel in my experience over the last well, really 30 years in science, rather than really scientific problem oriented, or even decision making problem oriented. So some of this culture comes with placing a really high value on particular things. So we place high value on really specific statistical results, like point estimates, p-values for some. We place a high value on statistical analysis itself and often because it's seen as this objective and rigorous way to proceed. We place value on following strict formats in reporting results, kind of over creativity and more context dependent work. Value mathematical details over kind of deep contextual justification. And definitely seeing this even seems to be getting worse, is this valuing the ability to use or develop software to fit models. Really this kind of statistics as a collection of R packages idea. So, okay, so this slide has a lot on it, and really I'm just gonna two slides that I'm gonna show just to make so what I did here is just like a really brief, like threw some things, rectangles up there to represent different parts of a research process, assuming that we're going to use statistical inference as part of that process. So we have like research problems and questions, thinking about it, design of study, collection of data. A big piece is like this focus, like the real goal is to make inferences, right? And all these other pieces are pieces that are going to help us try to make reasonable inferences at the end. So we have our statistical methods, we have our assumptions around those, which is a pretty big piece. And so the next slide I'm going to show just changes the size of these rectangles to show you what I feel like is the representation in terms of how things are valued in our current paradigm. So I think, so to me, I feel like this is we downplay the research problem, design, collection of data, even the making of inference part, and kind of blow up this statistical methods for data analysis piece. The assumptions piece is smaller, the math is bigger, the computing is bigger. So I'm just going to toggle between these for a second, just to kind of make my visual point here. So just kind of blowing up that whole piece and underemphasizing kind of those other aspects. So that's kind of my visual for what I feel like we're living in. So this methods focused idea is definitely not new. I mean, lots of people have this opinion, and it's been even stated in those words, at least from the 1960s. People were pointing this out. This quote is from a book called Willful Ignorance, The Mismeasure of Uncertainty by Herbert Weisberg, which I highly recommend, and I'll actually be referencing it further on in this talk as well. So there is today a broad presumption that the quality of scientific research depends much more on methodology than on personal expertise. So our emphasis tends to be on training scientists in technique rather than in, say, logic or creativity. This primarily methodological conception of science has in some areas led to a plethora of technically sophisticated but uninspired and trivial studies. So I'm not going to touch the last sentence right now, but I just want to, I think he says it really nicely. So a little bit, just a couple more things about the paradigm we're in before I'm going to go into actually a little bit of history. So this dichotomania, which has kind of received a lot of press attention recently, which I think is good, but we definitely have this desire, I think, just as humans, for yes, no answers. And we like to try to use statistical approaches to satisfy this in science. And I think this does oversimplify our scientific inferences through this over-reliance on statistical approaches used in a way that pretends they get us a yes or no answer. So I think that kind of permeates a lot of what I see as some of the problems in our current paradigm. And then the things like philosophy, history of science, maybe sociology, I would say, are really viewed as separate, like soft, maybe I should have said softer topics that are not directly useful to our day-to-day doing of science. So I think this is simply like the world that we are living in now, where things have become siloed and separate. And then there's the incentive systems problem, which I'm not going to go into detail on this either, like the funding and promotion, but it's often tied to statistical results, which in itself is kind of should be kind of at least a red flag to think through. Okay, so this all, like the fact that we even have to, we have to live and operate in some paradigm, but that's always a challenge, because the way that we judge or evaluate how well we're doing science or how we're doing science is not really separate from the system that we're operating within, right? We have this like kind of vicious cycle. And so some like philosopher, well, actually biologist turned historian philosopher Thomas Kuhn like talks a lot about paradigms and paradigm shifts, and the idea that you're like wrapped up in this kind of normal science doing your thing until there's some huge crisis, which then like kicks you out of that paradigm, and then we'll start another paradigm. But change it's just really hard to recognize from within. So as I've said before, just like this increased awareness of norms and better educating ourselves about how the current paradigm developed and why it continues. I don't really know why it continues, but speculate on why it continues, I think, is really important. And then the how and what we teach is super, super important. So often, we pass on implicit messages that we don't intend to, that what we're teaching is like the way to do things. Like there is no other way. This is just kind of how you do it. And I definitely felt that way after my first two, I was all the way through one master's degree before really thinking any different. So, are the formal and informal teachers of statistics aware of debates, unsettled foundations, or the historical path that led to where we are now? Do we talk about scientific culture and norms in classes? Like, it didn't happen for me very much until, I mean, I did put it into my classes when I started teaching some, but I still don't feel like I did it enough at all. So for the students out there, you can ask, ask your professors about it. They'll really love you. So here's my students. So how aware are statistics students? Well, I had the great opportunity few years ago now, I guess. I taught a course to upper division statistics undergraduate students. So these were juniors and seniors who had not had me as a teacher for any of their previous courses. And I called the course, it was a real mouthful, but I still like it, Statistical Inference and the Philosophy of Science in Practice. And it was a seminar course. There was only 8 students, and we really went through a lot of readings, philosophical readings, and other stats and science-based readings. And really, like, the main takeaway is that the students were completely shocked to learn of unsettled foundations or historical arguments, or that there were different perspectives on what was found in textbooks. So they just dedicated 2 years of their life to studying statistics and had no idea, like, this just hadn't come up in their education at all. And it completely challenged their previously held views that, like, how we use statistics in science is just a finished and polished product. And I think one of the things that was important for them and me, but it became very uncomfortable for them to, like, sit with that, because they were, like, happily speeding along their way of, like, I'm doing exactly what I should be doing, and I know exactly what I should do for these particular problems. And it really kind of threw a little philosophical crisis in their path. Maybe that's a little too strong, but it's something that I feel all the time. And I guess it, like, made me, it's like, oh, okay, so this is why, like, I'm always feeling this kind of, like, tension between, going forwards with our statistical approaches, but not spending enough time really thinking about the beginning. So I'm not saying we shouldn't use what's in the textbooks, but it's just that awareness of the limitations and where it came from. So, like, in the not so distant past, right, we had scientists were philosophers, philosophers were scientists. We didn't have the discipline boundaries and the silos that we have now. Things were that would creates a very different environment from what we're operating in now. And things like probability were the subject of debates and disagreements. And so for the kind of most of the remainder of the talk, I actually want to dig into kind of the history of probability a little bit more, just to kind of give you just kind of a sense of some of the disagreements, and maybe spark a little bit more curiosity on that front. And I will say I'll move to this one first. So this little bit of history on probability, a lot of what I'm including in this presentation is from Herbert Weisbord's work in the Willful Ignorance, where he has a lot of chapters, really in-depth collection of the history of probability and statistics. So I think that the first thing to really notice here is that my little timeline on the bottom goes from the 1600s to the 2000s. That's not really that long, right? So this doesn't even like this, and in it wasn't really until the 1700s that there became any quantitative type aspects to this kind of idea of probability. It wasn't the idea of probability that we have right now. So it was originally these ideas of kind of a strength of support, like how certain am I, but described in words, not quantified. And it wasn't related to any occurrence of events or anything. So, and once it started to be mathematical, it still wasn't really what we think about today, but it was just trying some quantifying to games of chance. So you can see, like, all the way through, there were a lot of philosophical debates about probability all the way through the early 1900s. And then at some point, they are still happening, but I will say, like, there were a lot of debates among practicing scientists throughout that whole time. And then there in the mid 1900s is when there became this kind of automatic that there was this decision. No, there wasn't actually an explicit decision, but it started to be used automatically for scientific inference, and that, like, kind of debate and arguing about it kind of goes into the background. So that is very recent in the past, in our history. So a really important piece of it is acknowledging the contrast between inference and games of chance, or very well-controlled processes, versus inductive inference in science. And I'm going to kind of come, hopefully at the end of this part of the presentation, I'll kind of come full circle back to this contrast. So this idea of like how much can we really take the ideas and the math that comes out of games of chance and apply it to real world problems to make scientific inferences. So this is a huge leap that we don't really think about as huge today. But it took quite a while for us to get there, and it's not an agreed upon thing even at this point for those who think hard about it. So just kind of stepping back to a little bit for that timeline, the roots in games of chance, so really comes from the fact that gambling was really widespread in the Middle Ages, and people became really concerned with equity and fairness during that time. And this one is when they led to using numeric odds, but it was pretty informal. Like there was no connection between odds and probability like we think about it today in terms of fractions of events having a particular outcome. So they weren't using that to express probability. And so I think it's actually pretty easy to argue from like how history, and I think that Weisberg does a pretty good job of setting this out, that modern mathematical probability is not really a natural or inevitable way to reason about uncertainty. So it came about because of lots of historic events and other things going on in society and culture at that time. And again, this extension beyond games of chance is a hard one. So in the 1650s was when there was finally some conceptual breakthroughs that pushed things toward where we are today. And this was Pascal and Fermat. And they sent games of chance problems back and forth to each other. And this was when the first kind of ideas of like, we can count chances as if any possible future cases might occur. So kind of this hypothetical, we could think about continuing to do this and think about how to actually quantify probability in that setting, or uncertainty for future events. But Fermat had to really convince Pascal of this usefulness of this like idea of hypothetical future events and chances. Like Pascal was not on board with that to begin with. Which I think is like super interesting, because that's such a fundamental part of what we typically learn first in like a first stats class. And we all know how hard it was. Well, maybe remember how hard it was to like initially wrap your head around that as a student. And even if you don't remember that, you definitely remember probably teaching a intro stats class and trying to put together this idea, this hypothetical sequence of events. I remember drawing like on the board, like here's our hypothetical land and here's our real land over here, and like to try to make this point, which I'm sure probably a lot of people have. So while it seems natural to us now, like there's still indications in our minds and experiences of like why it maybe took so long to get there. So Huygens wrote a book trying to capture some of these ideas in 1657 that was motivated by their discussion. So that's kind of the first book that's out there. But still at this point, there was no linking these ideas to broader problems in real world uncertainty. Like this was all about just games of chance and kind of just mathematical fun at this point more than anything. So here's a bigger historical picture, and kind of most of these like names and notes come from Weisberg's book, but after Pascal from the 1700s, from Bernoulli and de Moivre, we have kind of some of the first clear statements of modern mathematical probability. We actually have fractions of chances that are developed a little bit further, and defining probability as degrees of certainty using those fractions. So that's kind of when that first comes about. And then the next step goes to Bayes and Laplace, and I'll have a little bit more about Bayes on the next slide, I think, where Bayes is kind of the first to merge some of these ideas of probability obviously gave us conditional and inverse probabilities, was what we usually kind of focus on when we hear about Bayes. And at the time, it's really important to think like his contemporaries were not ready for it, right? They did not buy what he was saying or really want anything to much to do with it. Maybe Laplace is the one that will take it a little bit further. So Bayes' combined view, the one thing I want to point out here is that Bayes wasn't just after mathematical exercises or games of chance. So what he was after was actually the bigger problem of induction. Like, how do we generalize off past experiences or observations? And he thought that probability was material that you could use to develop tools to help us make inductive inferences. So this is like a huge step forward in terms of getting toward where we are now. So he can believe that you could use it to capture games of chance, but you could also use it to represent knowledge of uncertainty in general with some constraints. And then Laplace continued Bayes' ideas. So Laplace actually had a lot of I think if I remember correctly, he had a good friend who was in politics, and his friend like really wanted to try to use probability to like help with social problems, political. So I guess I put social, political, judicial areas. And so Laplace like didn't really kind of went along with the Bayes idea and really didn't have issues switching between, or like Bayes, did not have issues switching between from games of chance to complex natural phenomena. Like he was just going back and forth with the use of probability, but he didn't, like, according to historians and philosophers, like he never really fully articulated the reasons for why that was okay. Like, why can you model complicated phenomenon as if they just like represent games of chance? And like, what are we losing in that? And what are the limitations of that? So he really just gave these like, oh, it's self-evident and it's common sense. Like those were really what his justifications were. But so his book, Classic Probability, persisted like through that age of reason. But then in so he died in 1827, and basically by 1840, the meaning and uses of probability were seriously questioned again. So it kind of like was upended. He was accused of overreaching, of lack of justification, and probability was again like recognized as having a lot of different interpretations and potential meanings. So really like that complex, all the challenges and complexities that were there and talked about for a long time came back. However, like the mathematical properties that had been developed over the last like 100 or 150 years were generally accepted. So it was more that the meaning behind those mathematical representations and what it could be, the limitations for what it should be used for, were what we're still being kind of argued about and still are. So so the hard questions from the 1850s really are still here. We just don't talk about them as much. Like, what really is probability? What can probability actually capture or represent? How much does that meaning even matter? What are the limitations to its use? One big thing that comes up, that's coming up more today, is like, can it adequately represent individual events? So this is kind of becoming a bigger, getting a little bit more press or spotlight among statisticians because of like precision-based medicine and like trying to get these more individual-based inferences. And how well do metaphorical lottery ideas really represent complex phenomena in nature? So we're still, this is what people were struggling with years ago and still there. So Weisberg presents 4 common ideas, and I'm not going to go into any details. I'm just really putting this up there just so you can see these kind of different meanings or definitions that are put in this 2014 book. Right? We have the relative frequency, this logical relationship between degree of belief, propensity for an event to occur. And the relative frequency one is the one that obviously most people hear about in their first stats classes, but even within relative frequency, there's issues that we don't talk about enough. And I won't go into all the details on this slide either, but the reference class problem. So if you're going to talk about relative frequencies, you have to have some reference class to adopt for for inferences or how you're going to summarize or aggregate. And then the problem of a single case, which I kind of mentioned before. So we often speak about a particular future event or individual, but there's not, that's a hard conceptual jump. And actually von Mises, who's did a lot of work on this in history too, believed that probability as applied to an individual was actually meaningless. And there are others who hold that view as well. So probability, definitely not a fully, I don't know if fully accepted is the right word. Maybe I should have said just fully agreed upon. There's just a lot of unsettled work around it. And so here's just another quote from Weisberg that I really appreciate. Eventually, the angst felt by many intellectuals of the 19th century regarding probability and statistics gave way to agnosticism by the early 20th. Which I think is kind of where we're still like living, obviously. Probability became simply accepted as the logic of uncertainty without worrying what precisely the word meant. As a result, few moderns recognize that statistical reality applies to populations, but not necessarily to the individuals within those populations. So I found to focus mostly on the second sentence where we're like accepting it and the logic, but we're not really worrying about precisely what it means. We're like a pragmatic approach. So the debates and discussions do continue today, as I keep pointing out, but I think that the key is that we don't see or hear that much about it among scientists or even statisticians who are using probability-based methods on a daily basis to support scientific inferences and decision-making. So it's like it's happening amongst a small group that are really interested in it, but it's just not filtering enough into the mainstream, in my opinion. It may be increasing with the press on the replicability crisis a little bit, but I think it's kind of pushed. Yeah, I won't say much more about that right now, but at least there is like a talk about crisis, which has spurred a little bit more discussion in this realm. So before I end my kind of history and probability, I just want to come back to maybe some of the characters that you would you more used to hearing about and whose ideas are in the textbooks now. So what were Fisher's views? Well, Fisher did rely on the metaphorical lottery idea of probability, but his what I find fascinating contribution is really that he made this direct connection between metaphorical lottery idea and how we're going to make statistical inference by inserting this physical randomization, or you can think about random sampling as well. So he actually put a lottery idea into the design process, which then bought a probability model, that completely like justified the probability model that he was going to work on. So yes, he's using it for science and for inductive reasoning in science, but he really tied it explicitly to a chance game or a game of chance. So I think that piece is like really interesting to me historically. And he did accept the idea of these hypothetical constructs. And so that whole piece gave the randomization distributions and sampling distributions ideas. But he did view probability as something that was useful, but that's something to be handled with care. And he said this in a lot of places in his writings and talks. So there still is this tension that I'm kind of now circling back to what I said before between this mathematical probability or these like problems related to like just describing probability games of chance, probabilistic ideas, and then this inductive scientific inference. Like these are two very different things that can work together, but are not necessarily together. So when Neiman and Pearson came in the loop, and I won't go into a lot of there's been more written recently about kind of the back and forth between, or the arguments and not back and forth between Neiman and Pearson and Fisher. But Neiman and Pearson were more the mathematicians. So I think about it, right? Like Neiman and Pearson more the mathematicians and Fisher more the scientists. They were not comfortable with Fisher's kind of intuitive and practical justifications relative to scientific process. And they really thought that if it's going to be that the probability is going to be used, it should be used to make decisions. Like that's what would push science forward. And so they really go to assuming a data generating model and then work deductively to focus on error rates in a hypothetical infinite sequence of identical tests. So this is like this idea of tests and decisions, like gets us type 1 errors, type 2 errors, and power. And this is what really was adopted in textbooks and kind of quickly became the modern paradigm. And a lot of this, like speaking of social things, has to do with the power that they held in society at that time as well. And this is kind of when statistics shifted to being thought of as a subfield of mathematics, as opposed to kind of part of just science in general, or part of the applied scientists world. So another quote from Weisberg, I really agree with this one. So the time is ripe for renewal of interest in the philosophy and psychological aspects, and we could probably add more things there, of uncertainty quantification. So these have been virtually ignored for half a century in the mistaken belief that our current version of probability is a finished product that is fully adequate for every purpose. And yeah, something we should all sit with. So we don't want to ignore the deeper layers. So we can't just stop with the mathematical assumptions conditional on we're going to use a particular model. Really important to talk about and acknowledge the deeper layers of assumptions, even though it's hard and complicated. And yeah, it doesn't necessarily make life easier, which is a problem for change. So we have a lot of expectations for checking mathematical assumptions, right? You're expected to do those on your homework assignments, for your paper. But we don't really have a lot of expectations on students, in my opinion, and on researchers for going much deeper than that. So to the title of, so now I'm actually putting the cover of the book up and want to discuss the title of the book, because I think it's really important. So, and this idea that Herb has is, what are we actually willing to ignore? Because we can't go forward. We can't like condition on the fact that we're going to use statistical inference and all of its tools and techniques without at some point ignoring a lot. So mathematical probabilities and statistics used to estimate them depend on willful ignorance. So it is only by ignoring certain specific considerations pertaining to the event or statement in question that a mathematical probability becomes possible. So there's a lot here, and I definitely encourage you to read Herb's book, but we have to, it does require simplification. To use games of chance mathematics for a real world scientific inference problems and modeling real world complex phenomena, there has to be a lot of simplification that happens there. And just by just in the decision to use probability as the foundation or means, you've done a lot of simplification that we don't necessarily explicitly think about. So this is one of my, this is a Frank and Ernest cartoon that I just happened to like cut out of the paper, but it always makes me laugh. So I like to put it in when I'm talking about Herb's book. So enlightenment sounds okay, but I've decided to go with willful ignorance instead. So sometimes that's how I feel each day at work. Okay, and then here's a pretty famous quote now. I feel like this one's used a lot, which I think the fact that it's being used a lot is probably is actually a good thing, and they'll get indication that we're kind of becoming more aware of these issues. So the history of science has suffered greatly by the use of teachers of secondhand material and the consequent obliteration of the circumstances and intellectual atmosphere in which the great discoveries of the past were made. And so, yeah, I mean, I think that this definitely applies to where we are today. So just a couple more slides. I just wanted to point out another book that's a good one to start with if you haven't already read it. So The Lady Tasting Tea: How Statistics Revolutionized the 20th Century. And I really like the end when he gets a little bit more philosophical about things. So a couple of things that Salzberg says. So the basic idea behind the statistical revolution is that the reality science are distributions of numbers. This kind of gets back to my like methods focused idea. And as we enter the 21st century, the statistical revolution in science stands triumphant. It has become so widely used that its underlying assumptions have become part of the unspoken culture of the Western world. It stands triumphant on feet of clay. So where to go from here? So really, I mean, I hope it wasn't depressing. I hope this is actually curiosity provoking. But I mean, that was the goal, is just to kind of inspire more awareness and curiosity in the deeper foundations, even if it does bring some discomfort and questioning of what we're doing. Using statistical methods with more an air of caution, acknowledging that they are conditional on a lot that we don't talk about very often and have more limitations than we like to admit. It's recognizing cultural norms, I think, is super, super important. And I know, lastly, like valuing non-mathematical and non-methods focused work by statisticians who are interested in deeper foundations, I think is important. I did struggle in as kind of I wanted to change my research kind of focus when I was in academia, to focus more on this, but I was kind of advised not to do this by many people because of worries that the publications wouldn't count as much toward tenure, which probably was true given our culture. But I hope we can shift a little bit in that direction. Okay, so I put just some books and papers. I'm not going to read through these, but and this is not an exhaustive list at all. It's just kind of the ones that first came to mind, just to get people started if they would, if they're looking for a place to start. And that's all I have. Thanks so much.
Thank you, Megan. That was great. I wanted to find my copy of Willful Ignorance, but I haven't been able to just turn around and find it on my shelf here, but it is a great book. I'll second that. If there's anybody in the audience who wants to be allowed to talk, to ask their question, or wants to type something into the chat or the Q&A, that'd be great. I'll start with one while other people might think of things, but I've been in an academic setting. I've been, my wife teaches statistics at a high school. Is there an appropriate place to kind of start this revolution or bring this, or are there inappropriate places?
I think that's a great question. I think that starting it in high school is completely fine. I don't think it has to be we don't have to go into a full-on history lesson to let people know where things came from, but I think we do, even just saying like, hey, here's what we're learning, but there's a really interesting history that got us here, and there are other opinions and some people who don't agree with what I'm teaching right now. And I know that is hard, but I feel like that's all it would. I feel like just putting in that little bit of uncertainty is really important. That's what I tell my kids when their teachers come, tell them that this is how we should be doing everything.
I know a science teacher who talks about the frustration with all they get to do is teach the history of science, meaning what's already been discovered, and not the history, or not the act of doing science. And I think that applies to statistics a lot too. We teach the t-test, we don't teach how we got there.
Yeah.
Megan, there's quite a bit going on in the chat. I think now that you're not sharing, you might catch some of that. A lot of it is great talk that I agree with. There was one question. Do you think the move away from p-values is in line with the direction you've talked about?
Yeah, I do think it is. I think there are, I have serious concerns with how we've used p-values in science. I'm not anti p-value in all situations. I think it depends. But when you think about how p-values are used simply as a norm and as part of scientific culture with a little to no understanding of the foundations and when they might be appropriate, then yes, I think that is a problem. And I think that it has brought up more talk about the history and where they came from, just the recognition that there are issues and how they're being used.
there's a follow-up to that or a similar one. How do you use p-values in your statistical consulting?
That's a great question. So I don't use them much, if at all. But I would say there are times when I would. So if it was a very, very strict randomization test situation, and I could very clearly explain what the p-value was actually representing, I would not use a cutoff. I would not focus on type 1 errors, type 2 errors, or power, but in a kind of more Fisher approach of using a p-value. It's a statistic. It's a summary statistic. And if that summary statistic happens to give some valuable information, you can back that up with justification for why that's valuable information, then that's completely fine, in my opinion.
Fabulous. And from the Q&A box, do you think new methods in big data that account for the loosening of a lot of sampling assumptions are in line with your thinking, or are you envisioning a bigger paradigm shift?
Yeah, I think I'm envisioning a bigger, and I don't even know what shift I'm envisioning, to be honest, but I think it's more the idea that there are going to be shifts. And I think what's happening with machine learning and artificial intelligence is a paradigm shift in a lot of ways that's kind of spinning off. But that's not going to change what's happening in a lot of science that's still doing smaller based experiments. I don't think that I don't think it's helping with a lot of the cultural problems that I talked about today. But yeah, it's complicated.
Which is good. We like complicated things.
But we want to be aware of what's happening within the culture. Like, how is that being fed in? How are those ideas that I didn't really talk about in big data and machine learning? Like what scientific culture things are evolving around that are losing sight of its history. So it's kind of another stream of history and philosophy. Like, are we thinking about the philosophical foundations behind that before we apply it to all of these problems? So I guess I think about it kind of as another strand that has all the things that I said kind of apply in a different way to that.
Excellent. Shifting gears a little bit, are there any modern philosophers of statistics proposing other ways to view probability, like Laplace, Bayes, et cetera, did?
Yeah. So there are some, well, unfortunately, a lot of what's happening, at least what I see, and I'm like, so to be clear, like I don't get to spend a lot of time and immerse myself in this world. So the philosophers of statistics who are philosophers that I know are still spending a lot of time in the frequentist versus Bayesian kind of thinking about probability. And like Deborah Mayo does a lot of work about error statistics and the importance of accounting for errors, but that's still like embedded within kind of the Newman-Pearson original ideas. There are some philosophers of science who I think are getting more interested. So Alan Love has some, I just recently met him. He's got some really, I think, interesting and more general ideas from philosophy of science that can be brought in. So I think there's really a need right now for statisticians who understand how statistics is actually being used in science and who have that deep foundations in statistical inference and probability to partner with philosophers of science. And a lot more is happening in Europe, I should say, too. So I'm like on some listservs and hopefully we'll go to some conferences in Europe in the next couple of years, but they seem to be a little step ahead of us in thinking about some of these things.
Your talk has generated a lot of interest here, so we've got a whole bunch more questions. We're coming up on 6:30. I hope you can stick around and keep answering, but let me know if we get late. How sympathetic are you to the Bayesian point of view?
Yeah, so I really don't. I guess I think about, okay, well, we have these different definitions and ideas of probability. I'm not really I'm not really pro or anti any of them. Like, I think they make sense for different contexts. I use Bayesian inference quite a bit and taught the Bayesian class, have Bayesian advisors. So I definitely, I guess you could say I'm sympathetic to it, but I think my point is not really that we shouldn't use particular concepts of probability Ideas more be aware of the limitations of what we are deciding to do. So I definitely don't want to come across as like, I don't think we should use probability to represent like a subjective degree of belief or a general uncertainty. Like, I think that's fine to do as long as you can justify to me why you think that's a reasonable thing to do in that particular context. So that's the piece that I feel like is missing, is this underlying justification and even thinking about that. Really, it's a decision that we're making about those foundations. So what I see now is people being like, oh, I'm going to use Bayesian inference, and because I can fit it in a software package, I'm just going to do it. And that's like, I get my posterior distribution, but there's never really been that, besides recognizing, oh, there's frequentist versus Bayesian debate. And like, I don't know what to do there. We don't dig into the foundations.
Do you think having a science background is a hindrance or an advantage as a statistician and consultant?
I personally think it's an advantage, but I think it takes both kinds of statisticians. So I think there's, I had a really interesting experience as a graduate student with a science degree, with degrees in science before going to statistics. I definitely had very different strengths than the people coming straight from math. And I feel like we both brought different strengths and made it a different issue. I think if you come from science, at least in my experience, in other statisticians that I've met, those who come from science backgrounds tend to feel more similar to me in terms of, or to what I've expressed today in terms of concerns.
Speaking about that, people coming from math versus coming from science, in my measure theory course or probability theory course, I enjoyed it greatly coming from a math background, but it was everyone else's least favorite class. So
I was in the least favorite.
Yeah, exactly.
There. Yeah, I mean, it really is. It is really cool to look back at the history, like I talked about today, and think about all the problems the mathematicians worked on, and then this just general inductive problem, which definitely is where I was coming from. That's why I came to statistics, was before like inductive inference and trying to figure out how to do it. So yeah, there's very different motivations there, and we need both.
Yes. Just let's see. I guess this last one's just a comment, or at least I don't see the question. Smaller experiments versus bigger experiments is an interesting distinction I had thought of. I work in health science with lots of big insurance data sets, and I feel like this is still extremely important to keep in mind.
Yeah. Yeah.
Agreed. I don't see any hands up or unanswered questions or comments. If I'm wrong and somebody's got one, pop your hand up or type your question in.
I should say I missed one on any modern philosophers of statistics. So there's a mathematician from University of Washington, Christoph Birdsey, who's written a couple books recently and has some kind of alternative ideas for use of probability coming from a mathematical perspective. But anyway, that's another interesting one that's out there recently.
Great. All right. Well, thank you everyone for joining us. Thank you, Megan, very much for leading us through this for the last hour. I really enjoyed the tour, and there aren't easy solutions. I agree. That's, if there had been easy solutions, they would have been found in 1600. So keep up the good work, and everybody else, I have a good summer. I hope to see you in the fall at our next show, and we'll see some email about it. So thank you all. Good night.
Thanks so much, everybody.